per second. Anything short of that, it will not actually even power. Now, in this device here, there is a starter battery of that size. Let's have a look at this closely. And you can see, like, this has capacity to provide 45 amps of power, DC power, current, every hour. So an hour has about 3,600 seconds. If you divide the 45 by 3,600, you're going to see that the capacity it can provide is actually very little. Well, this one requires 34 seconds, 34 amps every hour. If the source were this, just like we've got right here, it cannot sustain this device
Beyond 10 seconds.
beyond even 1 second or 2 seconds. Okay? So if this is able to run for more than 2 seconds, that tells us that there must be an extra source of power coming from elsewhere. Okay, so that is what we would love to see and potentially demonstrate that there is another extra source of energy we are getting from this machine. And that is the actual proof of the concept that the team has managed to achieve and is looking forward to using the same concept for so many other applications. So if you could allow me to just plug this in, please. To get our three-phase power activated, relays, switch on. And apparently, you really cannot stop this. Like we stopped it there, you cannot stop this because it's running at its full potential. It has a force of 3 horsepower, apparently, and it will not show even any signs of stopping because it's constantly supplied with the energy it needs.
So it can even run potentially more powerful.
That's right. So the beauty of it is that once this is sustainable all year round, it can be used to run, like Professor said, more other devices, more other alternatives on a larger scale. And with that kind of concept, there is no limit to how much power you can generate. Only the finances can limit how many devices you can parallel and stack up. But it is the technology that really will not have a limit to how much energy you can produce. As far as hydroelectricity is concerned, you are limited to the structures, and so it limits how much output of energy you can have. You can only have maybe 600 megawatts, and that's it, because that is the size of how much you can go with the river. But with this, there is no size to how much. You can scale that up to even tens of thousands of megawatts. And it all started with, seems like madness, right? But it's not. It's a reality. And so this can be adapted and it can be used for so many other applications, both for single phase applications and applications on an industrial scale. Thank you so much.
Thank you.
So, any questions, Doctor? Engineers?
Sure, these folks here.
I will make John available to respond to this.
Any questions, guys? Because I'm more interested in how you stabilize the source, how you actually, the techniques.
It's temporary.
It's on the
In that way. In that setting well.
Did you design the board?
Yes, it's already.
Yes, please. We do the design of the boards ourselves. We solder all the electronics into it according to the specifications really required. This system is customizable for anything. If somebody says, oh, this is exactly what we need, then we design. Yes, we can rate it at different levels. This particular system is rated at 15 kVA, and it has applications for both single phase and three phase. And so devices that fall under 15 kVA of power can be comfortably powered on this continuously, unless switched off like Engineer Alpha has yesterday.
What's the longest time has run?
We've been able to test the system for about a year and a half now. It's continuously powering one of our hotels, and they've never got any interruption whatsoever. They are busy. They use it for various applications. They've got swimming pool water pumps, which are also three-phase induction motors, and they have lighting, ironing, cooking, boilers for heating the water, and they are comfortable at the moment.
1.5 years.
Yes, 1.5 years so far.
Continuously.
Continuously, 24/7, all year round. All year round.
So reliability is there.
The only service you may require is to boil the bearing.
Yes, the bearings, because the motors have double bearings on either side.
That's the only service.
Which is normal on a daily basis to do that. So,
Could you by any chance how much power was supposed to be
We've constantly been checking the data for that, and the beauty of the design of such systems is that they have automatic load detectors, which are embedded within the main circuitry. Yeah, you have a loop, and it detects the load that has been given it and adjusts all the parameters of the system according to what you have put in. That's why you can see I can plug a little bulb like this into the machine and it doesn't blow up. Why? Because that is detected and then given the power only that it requires, so that it's not like I will feed power into it and then it blows up. You've heard of engine generators blowing up equipment, burning houses and all that. They do not have load detectors. Whatever you plug in, even your cell phone will just be blown because there is nothing that is regulating the power to the load. So
board here.
We
Yeah,
can
we can, yes.
You can replicate that.
Yeah, we can fit it.
to add all of those.
So,
Which cooling system?
oh, it has automatic fans that are embedded inside, and then we have a thermal sensor. This white one here you see. It detects only when cooling is required, and then the fans come on automatically if it's not
So it's
required.
temperature control.
Yeah, it's a temperature control. So automatically it takes care of its temperature. Yeah, they're behind. Automatically they come on occasionally and off when needed.
So maximum load. But that's going to affect the heater. That's
They do not. The beauty of this system is that it runs entirely on electromagnetism, and we don't get heat. With magnetic field principles, we don't get a lot of heat like the rest of the other technologies do. So that is the comfort with it. And these dudes here, wow, they're designed to run cool all year round. You can have this run for the next 10 years constantly and you're still getting there.
the industry, that's a good thing, be able to run water.
Yes.
So what's the initial cost of installation, say, for this unit? Because I'm thinking about rural health facilities that are
Yes, yes. And this will just power up.
that cannot be powered. So
They're not very expensive, really.
We have,
cost them just maintenance.
The initial, the community.
yes, allow me to revise the answer that.
Oh, the finance.
Yes. Aisha is the Finance and Administration Director, and she has all the figures.
And the facts.
So Aisha, help us roughly to produce something around 15, 20 kVA.
15, 20 kV normally costs around $8,000 complete, perfect, to your specifications. And it can be upped up if you need more than, just slightly on top of the 20 kV.
At 8,000.
Have you considered making a standard?
No,
Jerome, I mean, at $8,000 a unit.
Good question.
No, this is just as we say.
No, no, no.
We are just, but we are now in that process of designing something usable market.